This is an explanation of a kit I have assembled in order to build this project at a school makerspace. The makerspace in question does not have soldering equipment and vents, so I've done all the soldering on this kit as a way of speeding up the exercise and making it available to students who don't have the ability to solder on site. Let's open the box and see what's inside. We have one Arduino, we have a USB cable, and we have a single 1 meter strip of addressable RGB LEDs. I'm going to go ahead and lay this strip out so we can see the LEDs. The case itself is an ordinary plastic food container. Almost any shape and size will do. Over here, I've drilled a hole and attached a 3-pin JST connector that is designed to fit right into the RGB LEDs. This is a fairly standard connector for RGB LEDs. Over here I've tied a knot to keep the cable from pulling out. On the end of these 3 wires I have soldered jumper wires with pins. Notice that the color of the jumper wires does not match the color of the wires on the JST connector. That's because, unfortunately, the color of the wires on most of these JST connectors is designed to confuse just about anyone. Generally speaking, in electronics, black, green, or a dark color is a great choice for ground that helps you know which wire is ground. Unfortunately, the JST connector chose white for that, so I've changed that by soldering a nice black wire on there. They got red correctly for positive, and green in this case was data in, and I've soldered a white wire on there. Over here we have our rotational encoder with a knob glued on. This has been inserted into the plastic with some pre-drilled holes, and it's been clamped in. Onto the pins are soldered jumper wires. One side has 3 pins, and these are the two outer cables indicate the rotation, the middle is ground, and the other side has a single wire. This is the push button switch. On the bottom of the container is a little spot of Velcro, which is designed to hold the Arduino neatly into place such that the USB connector lines up with the hole I've placed on the side here. The process of connecting the jumper wires, the pins, to the headers on the Arduino is fairly straightforward. For the rotational encoder, I'm going to start with the side that has 3 wires, and I'm going to take the 2 outer jumper wires, and I'm going to connect them to pins 2 and 3. It does not really matter which pin goes into which socket, 2 or 3. If you do them one way, the rotation of the LEDs will be reversed when you turn the knob, which is really just fine in this case. If you don't like it, you can always swap them. The third wire, the middle wire on the side with 3, is black or green, and it's going to go into ground on the Arduino, which is labeled GND. These letters are a little bit small, so I'm going to look very carefully and line that up. Make sure you get it into the right one. The fourth wire, coming from the side that has just 1 wire on it, is going to go into pin 4 on the Arduino. So when we're done, we have something in pins 2, 3, 4, and ground on this side. Coming back over to the RGB LED connector, we have 3 pins. A dark one, a reddish one, and a third one which is data. The data pin, in this case it's white, is going to go right into pin 5 here. The red is going to go to VIN. That stands for voltage in, and that's whatever voltage is coming into either the battery connector or the USB connector. Be careful, I should comment. If you use the battery connector, you can put up to 15 volts into the battery connector. These LEDs are designed for 5 volts. So my advice about choosing VIN is connected with the fact that we're using the USB connector for a positive voltage source. The last wire, black, is going to go to ground on this side. Luckily, Arduinos give you about 3 connections for ground, which is very helpful. That's it for the connectors into the headers. I At this point, we can go ahead and connect the USB cable right here on the hole I've made for the USB side. Over here, I have a USB power connector, and we can see some lights light up. In this particular case, I've already uploaded the demonstration program onto this Arduino. And finally, I'm going to put the protective lid on this case. I'd like to take this time to comment that the reason I've been so careful to put this project into a plastic box is that the jumper wires and the header pins on the Arduino can be fragile. In a worst case scenario, wiggling the jumper too much can cause the pin to break off in the header of the Arduino, and that's extremely difficult to get out. So we want to protect it by giving it just some basic protection here. We would not want to throw this into a backpack with all the jumper wires hanging out and have it jumble around. That said, let's see a demonstration. Push the button and turn it, and we see our LED moving. Push it again. We see the second mode of our demonstration program going through the rainbow as we turn. And push one more time, and now we're controlling the speed of a dot that's flowing around. And one last time, and we see a rainbow train of LEDs going around in a circle. And one last push, and it's turned off. I actually pushed twice and it turned on again. There, now it's off. Well, thanks for watching. This was a demonstration of assembling a kit put together for this project. And to anyone who's having a set of students go through this project, I encourage doing the soldering in advance in order to keep the process of assembling and programming and seeing the results very quick and satisfying for a large group of students. Thanks so much.